Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is the procedural programming module. And in the last class we have started with chapter number 20, that is C under the Linux, that is how to use C under Linux operating system. We have already studied about how to use C under Windows programming or under Windows, that is known as Windows programming. And this chapter is how to do the C programming under the Linux. Linux is one of the operating system. In this we have discussed what are the content of this chapter, like what is Linux, C programming under Linux, Linux program, processes. So these are the content, and we have discussed in the last class three content, that is what is Linux, C programming under Linux, and the Hello Linux program. Now today I'm going to start with the next topic, that is the processes. But before this, let's take a quick review what we have covered in the last class about chapter number 20. So we have studied about these three topics in the last class, that is what is Linux, how to do the C programming under the Linux, and how to write the simple program that is simple or that simply prints Hello Linux. So this paragraph says that in the today's world, it is divided into two camps. That is, today's world programming or today programming world is divided into two major camps. What are the two camps? One is Windows and one is Linux. So there are two types. One is Windows and one is Linux. Linux is used or is used for drawing the attention of a programmer across the globe. That is, it is a worldwide globe and successfully created a community of its own. So Linux has various demands in the society, so it can create a community of its own. This paragraph also says that in the last four chapters we have discussed about the Windows programming, that is how to do the Windows programming, what is the syntax, and what is the header file included in the Windows programming, what is the mean by the main function, that is the Windows main function. That we have dealt with the last four chapters, that is main concentrated on the Windows programming. This and the next one would deal with the Linux programming, that is this chapter, and the next one chapter is dealing with the Linux programming. Then we have discussed with what is Linux. So in simple terms, in the first line it is saying Linux is a clone of Unix operating system, that is it is a base of the, or it is a part of the Unix operating system. Its kernel was written from scratch by Linus Torvalds. That is, its kernel means its base was written. That is, its base was written from the scratch by Linus Torvalds. Linus Torvalds is the name of the person. He is able to do the Linux programming. That he acts as a person and along with the assistant from a loosely team of the programmers across the world on the internet. That is, he along with the assistant of the programmers is using or is helpful in developing the Linux operating system. It has all the features that is available in this one. That is, it has all the features you would expect in a modern operating system. That is, it has all the features that you are or you should expect in a modern operating system. And Linux is capable completely free of cost. That is, there is no cost for the Linux. Several programs, framework, utility have been built around the Linux kernel. That is, there are so many programs, there are so many frameworks, utilities that have been built around the Linux kernel. A common user may not want the headache of downloading the kernel. That is, a common user I'm a common user, I'm a starter, let's example. And I cannot take the headache of downloading the kernel, Linux, going through the various steps. So for doing this task in a easiest way, many organizations have come forward, like Red Hat, in a Linux. These are the various popular distributions or organizations that make the download or that makes the user comfortable with the downloading of the Linux. Some of the examples are Red Hat, SUSE, Caldera, Debian, Mandrake, Slackware, etc. Each of them contains the same kernel but may contain different programs. That is, the kernel is same, but the programs, installation procedures, utilities, files, folders are different, but everything is same. So which one is better is a taste of the or is a matter of the taste, that it depends on the user to user, person to person, that how Linux is used, what are the applications, what are the libraries, what are the framework that is used in this one. Then we have also studied that it was first developed by the history of the Linux, that is it was first developed by the for the x86 based PC. So this x86 based PC is one of the oldest PC that is available. So it is first developed for the x86 based PC. These days it runs on the Sunspec, Motorola, and any machine that is available for the Linux. So these are the names of the machine that is available. So in current today or day-to-day life, these days it runs on these varieties or these pitch or these operating systems. Therefore, Linux works on literally every conceivable microprocessor architecture. Then next point says under Linux one is faced with simply too many choices of the Linux distribution. That is whenever we use the Linux, one is faced with simply too many choices that is available in the Linux. Graphical shells, managers, editors, compilers, linker, debugger, etc. For simplicity, in my opinion, I have chosen the following combinations. What is the combination that is available? That is a Linux distribution, console shell, graphical shell, editor, compiler. So this is the one of the simplest combination that is available in this. That what is a Linux distribution? That is how Linux will be distributed. That is done by the Red Hat Linux. Then console shell, that is bash. Then graphical shell, that is a KDE. Then writer, that write. Then compiler, GNU C and C++ compiler, that is GCC. Then we have discussed how to do the C programming under the Linux. That is how to apply the different styles, iterations, looping that is available in the C programming under the Linux. That is how to do the C programming under Linux. So first point says, how is C under Linux any different than C under DOS? That is how we assume or we consider that C programming or C is done under the Linux as well as the C is done under the DOS as well as C is done under the Windows. That is how they are different whenever we use the C under the Linux, under the DOS, under the Windows. Well, it is same as well as the different. That is somehow it is same and somehow it is different. Like what are the same content? For loop is same, while loop is same. Data types, control instructions, syntax. That means the structure is same, but the parts or the applications or the content is different. That means what are the same content? That is data type, control instructions, and overall syntax. The usage of the standard library functions is also the same, even though the implementation may be different under the different operating system. For example, a printf would work under all the operating system. So whenever we use the printf, then it works under the all the operating system, but the way it is defined is likely to be different for different operating system. That is, printf is same, but the content is different, but the way it is defined is totally different. In C++, it is defined as a cout. In C, it is defined as a printf. So it depends on the application to application. It depends on the programming language to programming language. The programmer, however, does not suffer because of this, since he can continue to call printf. That is, he can use the printf to make the printf continue. That is how to available the printf or how to use the printf statement. But there are similarity ends. That is, there are somehow similarity ends in the C programming whenever we do the C programming under the Linux, under the Windows, under the DOS. If we are to build programs then utilize the feature offered by the operating system, then things are bound to be different across operating system. For example, if we are able to write a C program that would create a window and display a message only hello. That is, simply creates a window and display a message that is hello at the point when the user clicks the left mouse button. The architecture is totally different, but the content, but the layout, but the syntax that is used in C programming is the same one. Then we have discussed about the Hello Linux program, that is how to do the Hello Linux program, that is the base of the program. So this is the simpler source code that is available under the C language, that is how to use in the Linux. So this is the simplest code, that is int main, simply prints the Hello Linux, then return 0. This program is same as compared to the console programming that is under the DOS and the Windows. And then we have discussed about what are the steps available to execute the same program that is available in Windows, that is available in C under the Linux. That is, the code is given. So how to execute these programs under the Linux? These are the steps available, that is how to follow or how to use these steps. So these are the steps. First one is type the program and save it by this one. At the command prompt, use this one cd, then compile the program using the GCC compiler as given below, that is the GCC hello.c. Then whenever there is a successful completion, there is a file, that is a executable file that is available, that is a.out, that is the output file that contains a machine code of the program which can now be executed. So these are the various steps that is available whenever we have to do the programming, C programming under the Linux. Then next point, the same executes the code by this one, then you should able to see the output. So these are the various steps that is available whenever we do the programming under the Linux. So first of all, type the program, then use the hello.c for jumping into the directory folder, then compile using GCC, then execute or make a successful compilation, then execute, then print the Hello Linux. So we have done with the, or we have gone through the complete cycle or compile execute cycle, that is a complete cycle of the Linux program. So now let's see what are the tasks, what are the roles, what are the terms that is available under the Linux, that is what are the content that is available under the Linux. So let's start with the first topic, that is the today's topic, that is the processes. That is, what is the process, or what are the types of processes, or what are processes in Linux. So this says, gone are the days when only one job task could be executed in memory at any time. That is, that days are gone when there is only a single task that is available under the Linux and we have to use that task only. So that days are gone or have gone only when only one job task should be executed in memory at any time. Today the modern operating system, that means the today's word, it is a modern operating system like Windows and Linux permits execution of several tasks simultaneously. That is, Linux also permits execution of the multiple tasks simultaneously. Hence, these operating systems are aptly known as multitasking operating system. Therefore, these operating systems, that is a Linux, Windows, are simply or is simply known as the multitasking operating system. In Linux, each running task is known as a process. So whenever there is a multitasking, that is whenever there is a role of doing the task again and again, that is known as the multitasking. So Linux permits execution of several tasks simultaneously. Hence these operating systems are known as the multitasking operating system. So in multitasking, what do you mean? That is only or more than one programs are executing at the same time. So in Linux, each running task is known as the process. Whenever there are multiple tasks that is running under the Linux, and each task in a process is known as the, or each task in a Linux is known as a process. That is, suppose there are 5 tasks, that means there are 5 . So in Linux, each running task is known as a process. Suppose there are 4 processes or there are 5 multiple processes that is running in a Linux at the same time. So each running task in a Linux is known as the process. That is, there are 5 processes, so there are 5 tasks, so there are total 5 processes. even though it may appear that several processes are being executed by the microprocessor simultaneously. In actuality, it is not so. That is, in when we see when we execute when we run Internet Explorer, Mozilla, Google Chrome, Word, Excel at the same time, we think that every process has been executed by the microprocessor simultaneously, but it is not the case. What happens is the microprocessor divides the execution time among all the running processes. That is, it is a duty of the operating system, that is the OS, that how to divide or how to divide equal time to the multiple task, multiple application that is running at the same time. Suppose, as per my example, at the same time Word, at the same time Excel, at the same time Internet Explorer, at the same time Google Chrome is working. For example, that is, more than one task is executing at the same time. So the microprocessor divides the execution time into the multiple running processes. That is, at the same time, multiple processors divide the execution time among the different processes. Therefore, each process gets the microprocessor attention in a round-robin manner. That is, there is an execution time. First of all, there is a time of the process 1. Then there is a time of the process 2. Then there is a time of the process 3. So all the processes are executing at the same time. Once the time slice allocated for a process expires, the operation that is been currently executing is put on hold, and the microprocessor now directs its attention to the next process. That is, once the currently executing is on the hold, then the microprocessor simply directs its attention to the next process that is given under the line next. That is, first of all, the time is allotted to the different processes in the same manner, in the round robin manner. Therefore, at any given moment of time, at any given moment, if we take the snapshot of memory, only one process is being executed by the microprocessor. So at the same time, if we are able to do the snapshot, if we are able to take the snapshots in the memory, then it is also possible that only one process is being executed by the microprocessor. The switching of processes happens so fast that we have or we get a false impression that the microprocessor is executing several processes simultaneously. That is, the processing is done so fast in a computer, so we think that it is going to be executed simultaneously. But that does not the case. They are executed by the microprocessor at the same time, but with different execution time given to the different processes at the in a round robin method. But we think that no, this process is working, or this is working, this is working. That is, more than one process is executing at the same time simultaneously. But that is not the case. The switching of process, this is the most important line. The switching of process is so fast that we get a false impression that the processor is, or the CPU is executing multiple tasks simultaneously. The scheduling of processes is done by a program that is known as the scheduler. So scheduler is the program that is done or that is able to do the scheduling of the processes, which is a vital component of the Linux operating system. So whenever we do the processing or whenever we do the scheduling, that is done by a program that is known as the scheduler. That is also a vital component of the Linux operating system. So scheduler is a program that is able to do the programming, or that is able to schedule the processes in a Linux operating system. The scheduler program is fairly complex. Before switching over to the next thread, it stores the information about the current process. So this says before switching over to the next thread, that is, before switching to the next process, it stores the information about the current process. This includes current value of CPU registers, content of the system stack and application stack, etc. When this process again gets the time slot, these values are restored. That is, when this process again gets the time, that is, for example, 5 processes are running, and the fourth one is switching, or I am on the fourth one, let's switch to the next one. So at the same time, it's moved to the next one or get the information about the current process. So when this process again gets the time slot, these values are restored. This process of shifting over from one thread to another is often known as the context switch. That is shifting from one part to another, from one process to another, that is known as the context switch in the operating system. Note that Linux uses primitive scheduling. So one is a scheduler that is able to, or that is a program that is helpful for scheduling the process. And the process or shifting, or the process of shifting, is known as the context switch. And the Linux generally uses the primitive scheduling, that is meaning thereby that the content or the context switch is performed as soon as the time slot allocated to the process is over. That is Linux uses the primitive scheduling no matter whether the process has completed its jobs or not. That is, proper time is given to the different processes, and if the process is able to do the or is able to execute the process, or is able to execute the task within that time slot, then it's okay. Otherwise the time or the process is or process is finished, that the time is finished for the process, and he or she is not able to, or it is not able to get the execution of the process. Then next paragraph says kernel assigns each process running in memory a unique ID. That is, kernel assigns or kernel allocates every process a unique ID that is available, that is help to differentiate with the different processes. Suppose there are 4 processes, P1, P2, P3, P4. So unique ID is given to the P1, unique ID is given to the P2, unique ID is given to the P3. That is, every process gets the unique ID in the memory to differentiate with the different running processes. This ID is often known as the process ID or simply PID. So in simple terms, this paragraph says that whenever different processes are executing in the memory, so kernel assigns different values to the different processes, and that values are totally unique one. And that values, or that alphanumeric value, that is any one, that is either characters, numeric, alphanumeric, that is known as the unique ID of a process that is able to differentiate with the different processes. This ID is known as the process ID or simply PID. So PID is a process ID that is used to differentiate between different processes. It is very simple to print the PID of a running process programmatically. This is the program that is able to achieve, that is how to print the PID of any process. Till now we have studied about in theory that there is a PID, there is a unique ID, there is a register. So now it's the time to do the C programming, so that we are able to catch up, or we are able to print the PID of a running process. So this is a process, there is a int main, then there is a printf, that is process ID equals to %d, then get PID function. There is a int main, then there is a printf statement. So this is the simplest program. Simply use the process ID that is equals to the %d, that is given the numeric value. Then there is a get ID, that is the function, that is function called in this one. Here getPID is a library function which returns the process ID of the calling process. That is, it is a library function that is available, or that returns the process ID of the calling process. When the execution of the program comes to an end, the process stands terminated. That is, whenever there is an execution, or when the execution of the program comes to the end, that is when the execution is over, the process stands terminated. Every time we run the program, a new process is created. So every time there is a new process, so we run the program, or every time when we run the program, a new process is created. Therefore, kernel assigns a new value or new ID to the process each time. That is, whenever there is a new process, whenever there is a new process, or the new kernel, or the new time zone, so every time kernel assigns a unique ID to the process each and every time. This can be verified by executing the several programs. Each time it would produce a different output. That is, every time it produces a different output that is given by the different process ID. So in simple terms, it is a program that shows how to get the PID or how to print the PID. It is a library function that is available in the header file. The library name of the function is getPID. And how we can print it? This is the program that is how to print the unique ID for a process, and there are different processes that is available in this one. So in this we have studied what is a process and what are the processes that is available in the C programming, in the Linux, and how to print the unique ID for the each and every process. That is, kernel assigns unique ID for the programming or for the programs or for the task or for the processes that is available in the Linux. So we can call it as a process, we can call it as a different programs, we can call it as a different task. So we can given or we can assign or we can take any name of the process. This can be verified by executing the program several times. Each time it would produce a different output. Then next one is your parent and child processes. That is, what is the parent process and what is the child processes. As we know, our running program is a process. That is, our running program that is available is a process. From this process we can create another process. That is, whenever we want to create a process, whenever we execute the process, every running program is a process, and whenever we can create the process, we can execute the process. So there is a parent-child relationship among the processes. The next topic is your parent-child process. That is, how to or what is a parent-child and what is the what is the parent process, what is the child process. So as we know, every running program is a process. That is, if there are multiple or there are 5 tasks, so that means there are 5 processes. So every running program that is available in the Windows, in the any operating system, that is known as the process. From this process we can create another process. That is, whenever there is one process, we can create the another process. So there is a parent-child relationship. That is, there is one parent, there is one child, or there are of 2 child, 3 child, any n number of childs between 2 processes. The way to achieve this is by using a library function that is a fork function. That is, whenever we want to create a chain, that is, one process creates another process. For creating one process from another process, that is done by the fork. That function or the fork function splits the running process into 2 processes. That is, whenever we use the fork function, so this function has a capability to split the running process into different processes, into 2 processes. The existing one is known as the parent and the new process is known as the child. So there are 2 types of processes. One is the parent, one is the child, and the fork function is used for doing the operation, that is the parent process and the child process. So here is a program that looks like, yeah, this is the most important one. This is the new header file that is used. Why we are using this one? Because the fork function is stored in this one. So this is the header file, that is syst oblique, that is a slash types.h. So this is the header file that is used for getting the library function that is available under the hash include sys types.h. Then there is a int main, then there is a printf, that is before forking. That is, what is the content before forking? Then there is a fork function, then printf after forking, that is used after forking. So one is before forking, then fork, then after forking. Int main, then there is a return 0 at the end of this chapter, or at the end of this printf. Then this is the output of the program, that is before forking, and there is a after forking. This is after forking, this is after forking. Why there are 2 times that is after forking? Because this is printed at the one time. Then there is a function calling, that is a function call, that is a fork function. So whenever we fork the function, then simply printf after the forking. So this is after forking, this is after forking. Watch the output of the program. You can notice that all the statement after the fork are executed twice. That is, whatever the statement after the fork or inside the fork function, that is executed multiple parts. Why? Because this line says this function splits the running process into the 2 processes. So this is the function capability to split the same running process, that is only single process is executing or is divided into two processes. The existing one is known as the parent and the new process is known as the child. Here is a program that demonstrates this. So this is there are two or this block is executed for the two times. One is for the parent, one is for the child. In other words, the fork has to manage or has managed to split out the process into two parts. That is, we have to split the process into two parts. That is done by the fork function. But why on earth would we like to do this? That is why there is a, or why we are given a time that we are able to do this. Why we are on the earth. At times we want our program to perform two jobs simultaneously. That is there are some conditions when we want or when my requirement is that I want to or I want that my or our program can perform or are able to perform two jobs simultaneously. That is there are some scenarios. Since these jobs may be interrelated, we may not want to create two different programs to perform them. That is, our jobs are interrelated with each other. So we may not want to create two processes or two different programs to perform them. Let me give you an example. So this is an example that when we want that only one program can perform multiple tasks simultaneously, so that only one program is executing in the memory at the same time, and there are multiple processes, there are multiple jobs that work under that only one program. Let me give you an example. Suppose we want to perform two jobs. One is used for copying the content of the source file to the target file and display an animated file indicating that the file copy is in progress. This is the first, there are two types of jobs. One is copying the content from the source file to the target file, and another one is display an GIF file that indicates that the file copy is in the progress. The GIF file should continue to play till file copy is taking place. That is, this file, that is the GIF file, should continue to play until this process or until file copy is taking place. Once the copying is over, the playing of the GIF file should be stopped. That is, both the files are or both the processes or both the jobs are working at the same time. Since both these are interrelated. Why interrelated? Because first of all, copy the content and then display only that content only in an animated file. So that should continue to play till file copy is taking place. When the copying is over, the playing of the GIF should be stopped. That is, the copying and the playing is continuing at the same time. So since these are interrelated, they cannot be performed in two different programs. Also, they cannot be performed one after the another, but they should be performed simultaneously. That is, they must be performed simultaneously at the same time. At such times, we would face to or we would want to use the fork function to create a child process and then write the program in such a manner that file copy is done by the parent and displaying of the animated GIF file is done by the child process. So in these scenarios, we want a function, that is a fork function, that divides the same process into two parts. What are the two parts? One is for the parent, one is for the child. So this says we would want to use the fork function to create a child process and then write the program in such a manner that the file copy is done by the parent and displaying or animated GIF file is done by the child process. So simply file copy is done by the parent process and animated GIF file is done by the child process. And both these divisions are done by the fork function. So fork is used to divide into two parts. One is parents, one is child, and parent is able to use the copy function and the child is used to display the animated GIF. The following program shows how this can be achieved. So this is a program that shows that how this can be achieved, how we can or how we can able to perform these tasks simultaneously at the same time. Note that the issue here is to show how to perform two different but interrelated jobs simultaneously. Hence, I have skipped the actual code for the file copying and playing the animated GIF file. That is, this is a very lengthy program if I show that how to copy the file from one part to another. So this says it is only to show how to perform two different but interrelated jobs simultaneously. So the file copying code is missing or skipped. This is the same header file, that is the hash include sys types.h. This is the header file that is installed that is used in this one. Then there is a int main for main function. Then there is a int PID, that is a process ID that is used. Then PID equals to fork. That is fork function is used for calling the function, and the PID is used for this one, that is the process ID. Then check the condition. What is the condition? If PID equals to 0, that is if the process ID is equals to the 0, then printf in child process. That is if it is equals to the 0, then simply print the statement that is we are in the child process if the PID is equals to 0. That is the what do you mean by child process? That is the code to play the animated GIF file. Else, so this is the closing curly brace, this is the opening, and this is the closing. Else, that is this is the else part of the if printf in parent process. So this is in parent process, that is a code to copy the file. This is also closed, this is also closed. So this is the int main, this is the PID that is equals to the fork function. Then check the condition. If it is equals to the 0, then simply printf, that is if the process ID is equals to 0, then simply get the child processes, or in the child processes, that is the code to play the animated GIF file. Otherwise, if it is not PID is equal to 0, then otherwise it is in the parent process, that is a code to copy the file, that is done by the fork function. So this is the most important part. Whenever we use the fork function, the output of this is displayed in the PID. If this function divides into two parts, that is equal to 0, that is the fork function is only a child process, that is equals to 0, that is a child process. If it is not equals to 0, that is other value than the 0, then that is in the parent process, that is only for copy the content. As we know, fork creates a child process and duplicates the code of the parent process in the child process. That is, as we know that fork function splits into two parts. One is the child process, one is the parent process. So fork creates a child process and duplicates the code of the parent process in the child process. Then there onwards, the execution of the fork function continue in both the processes. So this is the scenario that the execution of the fork function that continue in both the processes. Therefore, the duplication code inside fork function is executed only once. That is, there are two parts of the fork function. One is parent, one is child. So if the same function is repeated two times, that means there is a duplicacy of the different function that is available or that is executed by the fork function. But in that case, only one function is called by using the fork function, whereas the remaining code inside it is executing in both the parent and the child process. Hence, control would come back to the fork function twice, even though it is actually called only once. That is, it is mandatory to it is coming at the two times. Why? Because the parent and the child process is used at the same time. When the control returns from fork function of the parent process, it returns the PID of the child process. Whereas when control returns from the fork function of the child process, it always returns a 0. So whenever it returns from the fork function of the parent process, it returns the PID of the child process, and whenever the control transfer to the fork function of the child process is always returned the 0. Why? Because in the starting we have checked the condition if it is what equals to the 0, and we have also checked the condition if it returns the PID of the child process. This can be exploited by our program to segregate the code that we want to execute in the parent process from the code that we want to execute in the child process. That is, this method is able to achieve that how to make the differentiate between the child process and the parent process. So we have done in this program, in our program, using if statement. In the parent block, the else block would get executed otherwise, whereas in the child process if block would be executed. So whenever there is a child block, the first part, that is the if of first part, is executed. Then if it is the case of the parent process, then the second part is executed, that is after the else. Let us now write one more program. This program would use the fork to call a create a child process. So now this program would show or would use the fork function call to create a child process. That is how to create a child process. In the child process, we would print the, or we would first print the PID of the child and its parent, whereas in the parent process we would print the PID of the parent and its child. That is the both the processes, that is the child process and parent process, are able to execute or print the PID of the child parent individually by keeping in mind if that there is a child process that is able to print the PID. The first one is that is in this case the PID of the child is used and its parents, whereas in the parent process the PID of the parent is used or its child. Now this is the program that shows how this can be achieved. But before doing this program, first of all let's move to the practical approach. Then in the tomorrow's class I will be starting or in the tomorrow's class, or today is Friday. No. So in the 27th of January class. Why 27th? Because 26th, on 26th, that is on Monday, there is no class. Okay, so now the class is on 27th. So in the 27th class I will discuss this program, but this is not complete program, this is not how I've started. So now let's move to the practical approach, how to do the practical approach under the C programming, under the same similar C programming, that is a Windows programming, that is a, or C programming, that is how to do the C program under the Windows, MS-DOS. So now let's move to the practical approach. In the last class we have covered, that is how to that is in the last class we have started with the function, that is how to use the functions under the C programming, and we have built one small program, that is how to print the addition of two numbers. So now I'm going to continue to with the same topic, that is the functions, that is how to use the function. Oh, it is a program that is used to define user-defined functions. So first program that we have studied about the function calling, function definition, that is return a plus b. Now the next part, or the today's topic, is to write a program to define the user-defined functions. So this is the program. this is the name of the program, that is how to write a program to define the user defined function and call them at the different places. So now the same process, that is first of all hash include stdio.h, that is hash include conio.h. This is the next header file. Now let's define any function first of all, because it is user defined function. First of all, let's example void y. Alright, this is also a function. Then this is a function calling, so we have to give the semicolon over here. Then this is simply the function, that is void. Then there is a curly braces. Then simply printf. Then simply use the printf, that is printf, and there is a y. Then simply close this one. Now this is the name of the function, that is a user defined function, so we have to define this one, user defined function. This is the user defined function. So this is the simply a program, that is how to use or how to define the user defined functions and how to call them at different processes as per my requirement. That is how to use that one. Now let's start with the main functions. This is just a function definition, function declaration. These are the just two program. Now let's start with the main function, that is a void main function. Then start with this one. Then first of all use the function name, that is a for example, b for example, d for example, then e for example. Suppose only 4 value, because what we have given is totally different. Then there is a semicolon. Now there is a clear screen for clearing the screen. Then uses the different functions over here only, that is function calling. So these void are the function definition, and next one is the function calling. That is y function is called a c. Then this is the closing of the this one, that is now we have to define the different functions over here. That is first of all void a. Now if I compile this code, Then simply printf, then call the function again, that is a y function. And then there is a definition of the void b, that is, this is the definition of the void b, that is how void b is used. In the same way void b, in the same way void c, in the same way void d. Then simply printf, then in this we have to call another function, that is the a function. Now we have to define the third function, that is a c. Then simply printf uses the printf. Now we have to declare the function either b, either c, or we can call any other function, that is a. Now this is also a function calling, then b, then now it's a time to declare or define the function of the d. Now the C work has been over, so please close it first of all. Now it's the time to declare the void d, that is what is the content of the void d, that is the content. So simply printf, then call the three functions again, that is c, b, a. Then simply, now if I compile this code, there are 6 errors. First of all says that the size of y is unknown or 0, that is the size of y is unknown or 0, that is not available over there. Type mismatch is declaration of the y, size of y is unknown or 0. 888. A, one is B, one is C. Now if I compile this code, declaration size of y, declaration syntax error, 38 line, y, because we have used the y and there is no space for the y. This is known as the undefined symbol, that is not defined over here. So this is the program that shows how user defined functions is available and how we can call them at the multiple places. There is a B, there is a C, there is a B. In 30th line, in the C part, there are two parts, and then there is a this one. Now, if I declare this one in the above, that is after the C, and this is above the C. If I cut into this one, and if I print over here, now if I compile this code, there are 8 errors. Size of Y expected 37, 39. C have a prototype, that is C must have a prototype, that is A, first of all A, then B, then C, and simply print the statement that is done by the printer. Then there is a D function that is used, that is how the D will be used. This is the program that is not executed. Now if I save it by the, or if I save as by the .c, that is star or star.c. This is also a star.c. If I give the name as a user define. Now if I compile this code, there are only 5 errors because 3 errors is only for the C++. Size of Y, type mismatch, declaration syntax error. That is 8th line, there are multiple parts. This is the 8th line. This is not in given, that is this is not in given, that is how it will be used. Simply printf, that is the Y, and this is the function calling, then there is a Y. So first of all there is a Y, then A, so it is declared in the outside function, that is Y is declared and Y is used. And what about line 37? This is the complicated program. This is also a syntax error, I think so. This is what we have printed, the capital letter. Now if I compile this code, there are 5 errors. 37, 39 expected. Now simply print the statement. Then there is a void D. This is in the terms of this one, then A, then B, then C, then there is a closing braces. One more is expected over here, that is used over here, then A, B, C, D, E. There are multiple parts that is used, and these are the various functions that is declared over here. And this one, there is a curly braces. Then this is a function definition. First of all it is declared, then there is a void main, then printf, that is equals to the 0. Now if I execute this code, now let's see, there are 5 errors. Size of Y is unknown, 0, type mismatch, declaration syntax error. So if I cannot give this one, now if I execute this code, there are 4 errors. Size of Y is unknown, 0, that is the size of Y is not given, that is what is the size of this one. This is the Y, this is again Y, then there are some void functions, that is A, B, C, D, then there is a clear screen, then these functions are calling 4 errors. 37, 38. There is a expected. Okay, this is not a correct bracket. Now if I compile this code, there are only two errors. One is declaration syntax error, that is this is wrongly declared. Now what is wrong in this one? There is a void, then there is a void, this is conio.h. Now if I write this one, that is y. Now let's see, there are three errors: size of y, non types of mismatch, declaration syntax error. That is, this is not known, but we have used this one. That is a y. Then there is a void. Then simply uses the printf for printing into the output. Then if it is not given, it is not a case. Now if I compile this one, there is only one error. That is a declaration syntax error. That is the simply the error that is given over here. That is, this is the declaration syntax error that is not available. Now if I compile this code, there are three errors: size of y is not and वगैरह वगैरह. Now if I compile this code, there is only one error, that is a declaration syntax error. There is a syntax error in this, how it will be declared. This is mandatory that it is arrive over here. Alright, this is a function and we have not used over here. Now if I compile this, there is a success. So this is the main problem. Now if I compile this code, the program will execute, but the output is not present. Why? Because we have not used the getch over here. So you use the getch over here, that is after the main function, that is a getch. Then there is a function. Now if I compile this, execute this code, this is the output that is printed. So first of all there is a y, then there is a, then there is a y, then there is a b, then there is a, then there is a y, then a, b, a, then y, then c, d, a, then y, b, a, then a, then b, a, then c. That means a will be printed multiple times, then b, a, then y, then c. Why there are so many times? Why? Because this is an outer loop that is in a block that is occupied, or these are the global variable that is shared by each and every term. So now let's see what is the use or how to do the dry run of this program. So these are the two header files that is used. One is the stdi.h, one is the conio.h. This is the function that is called over here. This is the definition of the function, and this is the global function that is available in each and every case of the function. So first of all, there is a void y, that is a function calling. Then there is a function definition, that is a void y. Then there is a printf y, that simply prints the value of the y, that is printf y, that is a capital Y. This is the void y. Then there is a void main, that is these functions are declared in this one, that is a, then b, then c, then d. So there are four functions that is available over here. Then there is a clear screen, that is clr, scr. Then these are the functions calling, that is multiple functions are called at the multiple places. There is a y function, that is first of all the y function is called. Then there is a function that is called, then b function, then c function, then d function. So whenever we execute or whenever we did the operation, it starts with the void main, as you know. So this is the function that is defined. So first of all the y function will be called. So whenever a y function will be called, this will be printed, that is a simply a y. Then a function will be called. So whenever there is a function, so simply prints the value of a. So a value will be printed, and then calling of the y function. It simply prints the capital Y. Right. This will terminate. Whenever there is a closing brace, the cursor moves to again to the this one. Right. Then there is a B part, that is gone to the, whenever the cursor places to this one, it directly gone to this one, that is a void B. This is Then there is a void printf b, that is b will be printed, and then a function. That means whenever cursor moves to this one, it directly moves to this one. This is the definition of a function. Now this function calls another function. That is how to use the multiple functions at the multiple places. This is void a, that is the function calling. This is the function definition. Then simply print the a and again call the y function. Whenever cursor puts over here, the cursor again moves to this one. That means for the b content, first of all the b will be printed, then a will be printed, then y will be printed. That is three items will be printed, that is b, a, y. Now let's see in the second iteration. This is the output. This is the second iteration, that is y, b, a, then again y. So this is b, then a, then again y. This is b, then a, then again y. Now whenever there is a function, that is function will be called, then the output will come over here. Now this is c, that is a c function. This is the void c. Then there is a function, that is whenever this cursor places over here, then the a will be placed over here. This simply prints the value of the a, that is a capital A. Then this is capital A, then again y function, that is capital Y, that is capital A and capital Y. So this is capital A, and then there is a Y, that is a capital Y. Right. Then there is a void B. This is the B. Then there is a B function, that is B, again A. So in this one, first of all A, then Y, then again B, then again A. That is A, Y, B, A, Y, and then C. Now let's see. This is A, Y, B, A, Y, then C. Now the next function is the D. In this, first of all the D will be printed, then there is a function. This is D, A, B, C, both the three functions. So first of all D will be printed, then in the A it is used A, capital A, then Y, right? Then B, then again capital A, then again capital Y, then again C, that is same A, B, A, B, A, B, C. So this is the output that arrives over here. And at last there is a C. Why? Because this is calling the C function, and in the C function this is the last that will be printed. So at the output, this is at the end, that is the C. So this is how to use the user defined functions at different places, and how these will be printed at the different scenarios at different places. So this is the use of the user defined functions, how this will be used and how we can call each and every function. Now if I change to this one, if I make the program simple or simpler, again simply uses this one, that is simply use 1, then 2, then 3. Now if I compile this code, there is a success. If I execute this code, the three values will be printed, that is y, a, y. Why? Because these are not functions that is in the progress. Then only two functions are used. One is the y function. So whenever there is a y function, the output comes over here. Simply y will be printed. Now a function, whenever the cursor over here, this will go into this one. That simply prints a. Then again y, that is again y. So this first of all y, then a, then again this is the y. So three output is available. One is y, then a, then y. So these are the three output that is available in the or on the screen, that is a y, a, y. Right. Now if I build this one, that is if I close this one and simply use this one. Now let's see. simply bay. Now let's see. Whenever cursor moves to this one, this will directly jumps to the b1. This is b, then a. This is a. This is a will be printed capital A. Then y. In y function there is a capital Y that will be printed. Right. So whenever there is a calling function of the b, first of all this will be printed, that is b. Then simply capital A and then capital Y. Why? Because this is capital N, this is capital Y, and this is the A function. So BAY is the output. Now let's see. BAY is the output. So this is the way how it will be executed. Now if I see only the D function, because that contains each and every function. If it is the case of the only D function. Then if I compile this code, the same output, that is a long output, first of all DAY, BAY, AYB, AYC. So this will be printed. Why? Because in this we have called the three functions, that is first of all the D will be printed as it is. So that's why in the output the D will be printed as it is first of all. Then there is the A function, that means A and Y. Then B function, then AYB. Then C function, that is the AY, then B, AY, then C. So at last there is a C, capital C. So at last there is a capital C. So this is the way how we can call a user-defined function, or how we can use the user-defined function within the another function. So these are the various user-defined functions. Now there is no time left. So that's all for today's session. In case you have any doubts, then please text the doubt and I will answer you. And in the tomorrow's class, from the practical point of view, I will be starting you an important topic, not in the tomorrow's class, in the Tuesday's class, that is on the 27th of January class. I will be starting you a next topic in the practical part, that is a global variable and the local variable. That is, what is the global variable and what is the local variable. Right. So that's all for today's session. So I can quit up from this one. That is, simply decomment this one. First of all we commented on this one, then decomment on this one. Now again I want to combine. Okay, then simply quit the application. So in the next class I will be starting with the theoretical topic, that is a fork function, how to use the fork function and how to deal with the fork function. So now the class will be on the 27th of January. Today is 23rd of January. So 24th and 25th your weekend, that is Saturday, Sunday, and 24 in the 26th of January there is no class. So now the class will be on the 27th of January, that is on Tuesday. On Tuesday I will be starting your practical approach with the local and the global variable, and in the theoretical approach the same continuation of this one, that is how to use the fork function. This is the program of the fork function that I am covering in the next class, that is in the Tuesday's class, that is the 27th of January class. Alright, so that's all for today's session. Thank you so much everyone for listening me. Now still if you have any doubts, because this is a recording sessions or recorded sessions, so if there is any doubts, then please text the doubts or mail the doubts and I will answer you whenever I come to the class. So please text the doubts. Thank you so much everyone. Bye bye. So don't take tension. First of all, I am repeating again because I am not present right now, I agree, but please take the doubts, mail the doubts, and I will answer you positively to the each and everyone individually. Okay, all right, thanks a lot. Bye bye.